Very good morning, students. Welcome to IIT NEET Foundation, our Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 7th students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 7. Our ongoing chapter, that is chapter number 7, light. And today we are entering into the session number 3. So far we completed 2 classes in understanding the concept of light and various terminology of light. Right. So we'll continue where we left in the last class. But before that, let us recall, let us review what we learned till now in the light chapter, right? So this is our light, where we learn about so many terms, so many words related to the important properties of the light, like reflection. We have seen what is the reflection of light. It's the most important property of the light. That is, whenever light falls on substances, hard substances, it returns back into the medium. Such bouncing back of light is called reflection of light. So you have seen what is mirror, that is smooth and polished surface. So what is the real image? What is the virtual image? What is the plane mirror? So how the images are formed on plane mirror, already I told. You go and stand in front of the plane mirror and there are some characteristics you can see, right? Then what is the spherical mirrors? Spherical mirrors are obtained from a hollow sphere. Just like a spoon, I told, steel spoon. It acts as purely as a spherical mirror, maybe convex or concave mirror. It acts as both. One side convex, one side concave. We discussed about what is concave mirror, what is convex mirror. Right? One side is the inner part is coated with a silver and outer part acts as a reflecting medium is called concave. Inner part acts as a reflecting medium is called convex. Right? Convex mirror converges the light. Concave mirror diverges the light. All this we see, and of course we have seen about what is the laws of reflection. So incident ray, reflected ray, and normal lie on same plane. The angle of incident is equal to angle of reflection. Very important law that is. Then some general terms we discuss about the spherical mirrors, right? What is pole? The center, exactly the center part of the mirror is called the pole of the mirror. So whatever it may be, convex or concave, no matter, exactly the geometrical center. Geometrical center of the given mirror is called, for example, it may be convex or concave, no matter. Suppose if it is like this or like this, no matter. This geometrical center is called pole of a mirror. Then radius of curvature, the radius of the hollow sphere, imaginary radius, hollow sphere, which is a part of the either convex or concave. Aperture, again geometrical point. Principal axis, an imaginary line passing through the pole. An imaginary line passing through the pole is called like this, imaginary. That's why I show it as dotted line. This imaginary line is called principal axis. So principal focus, very important. So whenever light falls on the reflecting surface, either it converges or appears to converges at one point. That point is called principal focus. Very important. These definitions are helpful for even for the upcoming lenses also. See here. Here they are after reflection. What happened? They are coming back and they are meeting here. Right? They are meeting at this particular point. This point is called focus. This point is called focus. This is diverging, that is concave, converging, convex. After striking here, see the two parallel lines comes, strikes here and reflect back and meeting at this point, which is half. which is always half of the radius of curvature. Right? So pole is this, P is the pole, and P, small p is the principal focus, and C is the center of curvature. Right? So focal length. It is the distance between the principal focus and pole of the mirror. From here to pole, here to here. This is called the focal length. That is power. Our when specs power also measured in the is called as a focal length only. The power of the mirror. Okay. So these are the all terminology we learned in the earlier classes up to focal length. Now, very interesting part, already we discussed in the last class, outlines. Rules for obtaining the image found by the spherical mirror. So to obtain the image, how the image will come. Further, there are some rules are these, standard rules. Any ray of light traveling parallel to the principal axis. See, this is the principal axis. Suppose we are parallel line is there. This is parallel. A ray parallel is gone and strikes the reflecting surface of the convex mirror here. Here it is striking, right? After that, see how it is going? It is passes through the focal length mirror. After reflection, passes or appears to pass through the principal focus. See, this passes through the principal focus. So any parallel ray parallel to the principal axis, after striking the reflecting surface, it passes through focus only. Either it is a convex or concave. See, striking here. So it passes through the focal, principal focus. That is one kind of rule. First rule. It is a mandatory. Second rule is, a ray of light passes or appears to passes principal focus. Suppose, first time you have parallel line. Now, this is the line. A line is passing through the principal focus. After reflection, go parallel. Means, same, reverse. If it is a parallel line, strikes the point and reflects, it passes through principal focus. If the line passes through the focus, principal focus, after hitting the reflecting surface, goes parallel. See, the direction is very important. It is towards, it is away. It is towards, it is away. Both are correct. Either it is a convex or concave. No matter, the rule is rule. Rule for all. Like, these are the two important rules. Either ray may be parallel to the principal axis. After reflection, it passes the focus. If the ray passes through the focus, after reflection, it is parallel to the principal axis. Right? Another one here, third one. A ray of light passes or appears to passes through center of curvature. This is. The mirror after reflection will retrace its path. Retrace. Again, same path. See here. Here we are passing the light from here. Passes through center of curvature and hits the reflecting surface. So after hitting, what happened? It again returns back. Retrace means moves along the same path. However it comes, it moves at the same path. No deviation at all. Along the same line it travels. That is called retrace. See here. So we are passing like this. It is coming back like that only. That is also third rule. Fourth one. A ray of light which is incident at pole of the mirror, convex or concave, is reflected back by making same angle with the principal axis. See, suppose we are incidenting like this at pole. So see, it is coming like this. So angle of incident is equal to angle of reflection. With what angle you are incidenting at pole? With same angle it reflect back. Reflect on the other side of the principal axis, which shows satisfy the law of reflection. Incident ray, reflected ray, and normal. Either it may be convex or concave, no matter. These are the four called, all these four rules are called rules of formation of the image found by the spherical mirror. Right? Very important rules. So before going for this understanding, very important, we have separated for concave and convex mirrors. I will show you one video on the rules. Okay. After seeing the video, we'll go for the further explanation.
After watching this video, you will be able to understand what are the rules for obtaining images formed by spherical mirrors. In our previous video, we have understood what are spherical mirrors and types of spherical mirrors. In this video, let us understand what are the certain rules for obtaining images formed by spherical mirrors. We can study the formation of images formed by spherical mirrors using ray diagrams. Ray diagram is a simple method of representing in which direction the incident rays get reflected. So ray diagram can be defined as a diagram that traces the path that light takes in order for a person to view a point on the image of an object. So complex objects such as people can often be represented by arrows. We construct ray diagram to find out the position, nature, and size of the images formed by spherical mirrors. Position of the image means if this is the ray diagram, concave mirror, this is the principal axis, so in which position the image of the object is formed on the principal axis. Nature of the image means whether the image formed is a real image or virtual image. Size of the object means the image formed is diminished or magnified image. We know that an infinite number of rays originate from object. So if this is an object, there are infinite number of rays which are originating from the object. It is convenient to consider only two rays for the sake of clarity of ray diagram. These rays make it easy to know their direction after reflection from the mirror. Now let's understand the rules for obtaining images formed by spherical mirrors. In the first rule, a ray of light is incident parallel to principal axis. In the second rule, a ray of light is passing through the principal focus.
Four rules I told, all the four rules I will explain here.
Third rule, when a ray of light is passing through the center of curvature, passing through the fourth rule, when a ray of light is incident at the pole.
Pole. The pole one is very interesting. That is satisfy the law of reflection.
So first let us consider the first case when a ray of light is parallel to principal axis. First of all, let us draw concave and convex mirror. This is the principal axis. So this is a concave and this is convex. This is the pole for a concave mirror. This is focus and center of curvature. Whereas for convex mirror, this is the pole, this is focus and this is center of curvature. When a ray of light is incident parallel to the principal axis for concave mirror, after reflection it will pass through the principal focus, as you can see here. So this is the incident ray and this is the reflected ray which is passing through the principal focus. Let's see what happens in the case of convex mirror. A ray of light which is parallel to principal axis appears to diverge from the principal focus. That is, this is the incident ray and the reflected ray appears to be diverging from the principal focus. The first rule is very clear that when a ray of light is parallel to principal axis for concave mirror, it passes through the principal focus. Whereas for convex mirror, a ray of light which is parallel to principal axis appears to diverge from the principal focus. In the second case, let's see in which direction a ray of light gets reflected when it passes through the principal focus. So this is a concave mirror which is curved inwards and this is the convex mirror whose reflecting surface is curved outwards. So this is pole, focus and center of curvature for concave mirror, pole, focus and center of curvature for convex mirror. So a ray of light passing through the principal focus of a concave mirror after reflection will merge parallel to the principal axis. That is, the incident ray which is passing through the principal focus after reflection will be parallel to principal axis. Let's see the case of convex mirror. When a ray of light which is directed towards the principal focus of a convex mirror So you can see the dotted lines, it is directed towards the principal focus of a convex mirror. So after reflection will merge parallel to the principal axis. So in both the cases, for both concave and convex mirror, so a ray of light which is passing through the principal focus for concave mirror and directed towards the principal focus for convex mirror, after reflection will merge parallel to the principal axis. In the third case, let's see in which direction a ray of light gets reflected when it passes through the center of curvature. So this is the third rule for obtaining the images formed by spherical mirror.
Traces back.
When a ray of light passes through the center of curvature for a concave mirror, after reflection is reflected back along the same path. So you can see here the incident ray is reflected back in the same direction. That is, the light rays trace back along the same path because the incident rays fall on the mirror along the normal to the reflecting surface. In case of convex mirror, when a ray of light is directed in the direction of center of curvature, so this is a ray of light which is directed in the direction of center of curvature, after reflection is reflected back along the same path. Can you see here?
Traces back.
Also got reflected in the same path. The third rule is very simple, which says that whenever a ray of light is passing through the center of curvature or directed towards the center of curvature, the reflected ray is traced back along the same path. In the fourth rule, let's see in which direction a ray of light gets reflected when it is incident towards the pole. In case of concave mirror, when a ray of light is incident at the
angle
pole,
of incident is equal to angle of reflection.
It is reflected back, making the same angle with the principal axis. That is, the angle of incidence made here will be equal to angle of reflection according to the law of reflection. So the angle of incidence is between the incident ray and the principal axis, whereas the angle of reflection is between the principal axis and the reflected ray. In case of convex mirror, a ray of light which is incident at the pole is reflected back, making the same angle with the principal axis. So again here angle of incidence will be equal to angle of reflection. These were the 4 important rules for obtaining images formed by spherical mirrors. Keeping these rules in mind, in our next video, we would be talking about the...
Okay, these are the 4 rules. Of course, 5th one also there, but in higher class you can come across. So those are the 4 rules for formation of images formed by the spherical mirror. Right? So, rules of obtaining the images formed by spherical mirrors. That is ray diagrams. They are called ray diagrams we are showing here. Now, next part when you come. So, images are forming. Okay. Concave mirror is giving images. Oh, so, what is that? Where, whenever object is placed at which position, what is the nature of image and what is the use? We can use that. That is nature. So, for concave, we are discussing now concave mirror. What is the nature of image formed by concave mirror? Position of image, size of image formed by the concave mirror. We have to see, right? Different cases. When you place the object in different positions of the concave mirror, what is the position of the object? What is the nature of the object? Size of the image? Everything, and what is the use? See here. First case. When the object is at light's infinity, when object is placed at infinite distance, the nature of the image formed is real image. Real means we can call on the screen. Inverted image, right? And diminished. Diminished means smaller than the original object size. Image formed at the focus. So, see here, focus is this. When you place the object somewhere infinity, right? Infinity, objects, what is the nature of the image? Real image, inverted image, and diminished image formed by the at focus. That is first case when object is placed at the infinity. Where this case is useful, ENT specialist, doctors, ENT, right? Specialist uses a concave mirror as a head mirror to concentrate light on the body parts like eye, ear, and nose. right? They'll use that whatever the light they use as the same type of case, where they'll place the object in infinity and they can see the real image, inverted image, and diminished, smaller than the original. Case 1. Next, case 2. When object is lies beyond the center of curvature. So this is center of curvature, beyond somewhere here. Infinity means so much too far, but it is the beyond, just back of the center of curvature when object is placed. AB is the object here. Right? What is the type? Image formed between the focus and the center of curvature. When your object is placed here, you will get the image, get the here. See here. Between focus and center of curvature. Here placing the object, image is forming here. And it is a real image, inverted image, and diminished image. Means you came from infinity to the beyond the center of curvature. Right? Very important. Let me show clearly. Center of curvature, focus, pole. Here, behind here, infinity is here somewhere. So first case is infinity, next beyond. When you keep the beyond here, so this is the size of object which is beyond the center of curvature. So between focus and this image is formed. That inverted image. And smaller size. Size also smaller when compared to the original object. Means as you are moving the object close, the image also moving towards the pole. First time infinite is there, the image is forming here at the center of curvature. When you brought the little bit front beyond the center of curvature, the image is moved towards the right side. Second case. So it is used in the reflecting telescope. When object is lies at the center of curvature, so from here we came here. This is object on SC. Infinity, beyond the center of curvature, at the center of curvature. Third case. So image formed is at the center of curvature. There only image is forming. Right? Center of curvature. Image is real, inverted, and same size of the object. This side, same. Why? Because you remember the third case rule. Traces back. Image is traces back and forming at the same center of curvature. Clear? As we are moving the image towards the right side, object right side image also moves towards same side. Okay, 3 cases are over. This video I will show you in the next class. Explanation. There is no particular use of this. When you go for next one, when object is lies between center of curvature and focus, means from center of curvature you move to the little forward. So this is a focus, this is a center of curvature. In between place the object here. Right? In between. The image formed is beyond the C. Beyond the C, which is real, inverted, and magnified. Means it's not diminished, magnified. More than the size of object. This case. So floodlight has the light source between the center and focus of the curvature mirror to spread the rays. Floodlights will be there in stadium. Cricket stadiums and all use the floodlights. They're all made of the same rule. Object is right between the center of curvature and the focus. Means from center of curvature move forward towards the focus. And last one, if you see, when object is lies at the center of focus, we move towards the F now. Object is came from infinity, beyond the center of curvature, at center of curvature, between center of curvature and focus. Now it came to focus. At focus. The image formed at the infinity. The real image, inverted and light, highly magnified. Very big one will get. So such lights, car headlights and flashlights have the light source near the focus of the concave mirror to use this properly. Right? So very highly magnified image is formed. Very big image. So they are using the such lights. The last case, from focus, again we are moving forward. When light object is in between focus and pole, moves from the focus to towards the pole. in between focus and pole. This is the pole, this is a focus. Here placed in between. The image formed is beyond the mirror, other side. So it's on other side of the mirror. Inverted, reverse only, and magnified. Larger than the size of object. Shaving mirrors, dental mirrors, makeup mirrors for ladies use this arrangement to get the virtual and magnified image. By seeing that, you can get the close magnified image. The two other side of the right. So these are the various positions when you place the object. What nature of images we are forming? What is the nature of image? What is the size of image? And what is the position of image? When you place the object at different positions on the principal axis, either starting from infinity to between pole and focus, or 4-5 positions, what kind of image is formed? What is the nature of image? What is the size of image is explained in a single table. In the case of concave mirror, it may be different for the convex mirror. We'll discuss in the next class. Convex mirror, only one case, all will come in one side only. So we'll discuss which is we discuss in the next class about the image formed by the convex, right? Clear, all of you? So, so today we learn about the very important, the two important topics along with video. One is the rules for obtaining the images found by the both mirror, that is convex or concave spherical mirrors. There are 4 rules are there, which are very simple way you can understand, because I showed through even video also. Then very beautiful table explains about the what is the nature, position, and size of image found by the concave mirror when object is placed at the different positions along the principal axis. When you are placing it infinity, then we came beyond the center of curvature, on center of curvature, between focus and center of curvature, on focus, between pole and focus. Means we are moving the image towards the right side. Same, the object towards right side. Image also moving on the same side. Finally, it moves beyond the mirror. Last case, image goes beyond the mirror. So first 2-3 cases, image is diminished. Then it becomes the increasing size up to the highly magnified. Right? So image size is increasing from diminished to highly magnified as it moves from the left to right along the principal axis. Clear? Same in the case of convex also happens. Maybe one case only. When object is placed, there are 2 only cases are there in case of concave mirror, convex mirror. Only 2 cases. So position and this explained given here. Separately given, very important. By seeing that, easily you can understand. This table completely clarifies you about the total explanation of the image formed, right? So that's all for today. So thank you, students. Thank you, everyone. Have a wonderful day. Thank you.